Hi, my name is Audrey, and I'm a member of the Teen Advisory Board with the Howard County Library System. And today, I'm going to be talking about the unit circle. But before we go on with this video, if you are not familiar with special right triangles, pause this video and go check out my special right triangles video. Now, before we talk about the unit circle itself, we're going to talk about degrees and radians. Degrees and radians are both units of measurement that measure the same thing, the size of an angle. You might be more familiar with degrees, but when we're talking about the unit circle, we're going to primarily be using radians. It's a pretty simple conversion from degrees to radians. You just take the degree and you multiply it by pi over 180, and then you get the number of radians. I have a chart here that's describing most of the values we'll be using today. 0 degrees is equal to 0 radians, 90 degrees is equal to pi over 2 radians, 180 degrees is equal to pi radians, 270 degrees is equal to 3 pi over 2 radians, and 360 degrees is equal to 2 pi radians. So over here we have an example of the unit circle. We have an x and y axis and a circle plotted on the graph. This circle has a radius of 1. That's very important. That's what makes it the unit circle. Its radius is exactly 1 unit. Now, we're going to take the axes of this circle and label them with the radians we just talked about. And we're going to be thinking of this a little bit differently than we would normally think about the axes of our graph. We're going to be thinking of it as in the angles out starting from this line and moving forward. So we've got this line here is some angle. That's how we're going to be labeling our axes. So this here, this starting line, if we were to draw two lines, they'd be right on top of each other. The angle between them would be 0. That is equal to 0 radians or 0 degrees. 0 radians or 0 degrees. Now let's say we drew another two lines. One here and one going up here. The angle between these lines would be equal to pi over 2 radians. Now if you go on in this way, you can find the degrees for every axis. The angle between these lines is 180 degrees, or pi radians. And if you take these lines and you go all the way around the long way, the angle will be 270 degrees, or 3 pi over 2 radians. The last angle we're going to mark here is as if we went all the way around the circle and came back. That's going to be the same exact point as 0, but we're going to label it as also 360 degrees, or 2 pi radians. So now we have the general axes of our graph. Now we're going to spend a lot of time setting up our unit circle. And you might be thinking, what's the point of all this? Why am I drawing all these lines? Why am I doing all this math? But I promise you, it'll make sense in the end, and the unit circle is a very, very important tool, especially when it comes to trigonometry. So bear with me for now. We're going to start out by dividing our circle into eighths. Now, since the total angle of our circle is 2 pi radians, or 360 degrees, when we divide it into eighths, we'll be dividing it into sections of pi over 4 radians, or 90 degrees. So let's draw some lines. Let's say pi over 4 is here, and then pi over 2, which we've already labeled. 3 pi over 4 is over here. And then we can go on, and down here is 5 pi over 4, since this one here is 3 pi over 4. And over here is going to be, that's kind of in the way. You know that the radius is 1. So down here we're going to have 7 pi over 4. So that is our unit circle divided into eighths. Next one we're going to do is divide it into sixths. So when we take 2 pi and we divide it into 6, we get sections of pi over 3. So since we know the whole top half of the circle is pi, when we divide it into when we divide it into sections of pi over 3, we'll be dividing each semicircle into thirds. So that's going to be around here. It's pi over 3. Here. Maybe a little. Here is 2 pi over 3. And then here would be where 3 pi over 3 is, but that's already labeled. It's pi. And then here would be 4 pi over 3. And here would be 5 pi over 3. And then 2 pi would be equal to 6 pi over 3. The last one we are going to do is divide our circle into 12ths. Now, when you divide 2 pi into 12 even sections, you get angles of pi over 6. So here, this will be our first angle. I can barely see that. Here will be our first angle, pi over 6. And then the next angle would be 2 pi over 6, but that's also equal to pi over 3. So we'll let that be. The next one would be 3 pi over 6, but that's also equal to pi over 2. So we'll let that be as well. And then 4 pi over 6, which is also equal to 2 pi over 3. Again, we've got that one labeled. The next one we're going to label is 5 pi over 6, right there. Just imagine that these lines are straight. That'll get you 5 pi over 6. And then we'll be labeling 7 pi over 6, which is right here. And the last one, 11 pi over 6. So as you're looking at this triangle, you can visualize the different sections. Like if you see this whole top semisphere, and then you start to shade it in, you can see that the blue section is 1/4 of this total top area. If you shade in another blue section, you can see that it's 1/2 of the top area, and so on. And being able to visualize that will be very helpful as you use the unit circle. You can do the same thing with pi over 3. You've got this section here, so you shade it in, and you can see that that's 1/3 of the top area. So on and so forth. So now that we've got our unit circle labeled, we're going to start talking about coordinates on the unit circle. Thank you all very much for watching. I hope that you found this video helpful.